Okay, now we are going to start the new chapter, which is amines. Okay, so what are amines and how we can prepare amines? So amines can be prepared by many methods. Like first, let's see, first method we can prepare amine from haloalkanes. Okay, so let's take an example. Let's see the reaction. Let's take one haloalkane, right? And when you put ammonia into it, right, at certain temperature, 373 Kelvin, so here ammonolysis will occur, right? So here cleavage of CX bond will occur. CX bond will break out and it will get partially negative charge and it will get partial positive charge, right? So from here, X, this X and one hydrogen, this will be removed as my HX, right? And first you will get primary amine, okay? Primary amine. Again, when you do the same process, just treat it with RX, right? Again, same procedure will will occur, right? So here again, X, this bond will cleave out, right? This bond will break out, and from here, X and HX will be removed, and you will get secondary amine. R2NH. This is a secondary amine. Like that, again, Rx minus HX, you will get tertiary amine. Again, if you do the same procedure, just treat it with Rx, what will happen? This bond will break out, and again, HX will be removed. And here you will get quaternary salt, N plus and X minus. This is a quaternary salt, right? Yeah, you can say quaternary amine. Now see, here is a mixture of primary, secondary, and tertiary amine along with the quaternary salt you will get, right, by the cleavage of CX bond by ammonia. And this process is known as ammonolysis. Known as ammonolysis. Okay. Next method is your by the reduction of nitro compounds. Let's see how. Second, it's very important for your exam by the reduction of nitro compounds. See what happens. Here, the reduction of nitro compounds to primary amines will occur, right? By using we can use SNCl, HCl, or FeHCl, or any strong reducing agent like lithium aluminum hydride, or the catalyst like H2 or nickel catalyst, right? To see the reaction are NO2 nitro compound So when you use SN, or you also use this, or you can use lithium aluminum hydride, or you can use H2 nickel catalyst. What all this reagent does, this will do reduction, right? So this nitro group will reduce to amine group, right? RNH2 plus water will lose. Got it? Hope you get it. Get my point, right? Next is your by reduction of cyanides and isocyanides. Again, it's very important. What happens when you reduce cyanide and what happens when you reduce isocyanide? In both the cases, a product will be different. Okay, so let's see how. First, let's take cyanides. R C triple bond N, right? We are doing hydrogenation. So when you do full hydrogenation in the presence of lithium aluminum hydride, which is a strong reducing agent, or you can use alcoholic NaOH, right? Or you can use H2 and nickel catalyst. So here full hydrogenation will occur and this cyanide, this RCN will reduce to the corresponding amine, which is a primary amine. You will get primary amine here. But in other ways, when we use isocyanide, so when we use isocyanide, which is RNC, and we do hydrogenation here, again the same reagent we will use. What will we get? We will get R, NH, and here CH3. So what's the difference between these two products? This is secondary amine. Okay. In the first case, we will get primary amine, while in the second one, we will get secondary amine. So the reduction of nitriles to primary amines by using sodium and alcohol is called Mendius reaction. Okay. Here we use alcoholic sodium. So write down this reduction nitriles to primary amines by using sodium and alcohol is called Mendius reaction. Okay. Okay. The fourth preparatory method of amine is uh, from amide. From amide. Okay. Let's see how. So amides on reduction with bromine, that is Br2, in an aqueous, or you can use ethanolic solution of NaOH. It gives primary amine, right? With one carbon atom less than that present in the amide. It's again very important, which is known as Hoffman bromamide degradation. Okay, just remember, if anywhere, if you want to achieve one carbonless compound, so do just Hoffman bromamide degradation reaction. Okay, so see what is Hoffman bromamide reaction degradation reaction. So let's see, when you take RCO NH2 and in the presence of Br2 and phenolic solution of NaOH, what happens? So you will get what happens here? What happens here? You will get one carbon atom less than that present in the amide, right? This will be removed and you will get this RNH2. Okay, this is NH2 plus sodium carbonate plus 2 NaBr. These are the byproducts. Okay, so this is Hoffman bromamide degradation. Okay, okay. The next one is your next preparatory method is your reduction of amides, right? So amide on reduction with, let's take an example. Amide, right? When you do reduction in the presence of lithium aluminum hydride, which is LiAlH4, right? And on hydration, what will you get? So this amide will, on reduction with LaH, it will yield amines. It will convert it into amine. Got it? Next, again, it's a very important, that is Gabriel halamide synthesis. Gabriel halamide synthesis. Okay. So in this reaction, halamide on treatment with alcoholic KOH forms potassium salt first, right? Potassium salt of thalamide. And again, on further heating with alkyl halide, followed by alkaline hydrolysis, produces primary amine. Let's see how. First, okay, so the reaction proceed like this. First, take the thalamide. Here CO bond, here again CO, and here NH. Right. On N, there is a negative charge, and H, positive charge. This is the thalamide. Okay. So when you treat thalamide by alcoholic KOH. What happens? So, you know that K plus and OH minus, right? So from here, this, see here, from water loss, dehydration will occur, right? And you will get the salt, CO, here again CO, and here N minus and K plus. Got it? So this is a salt, salt of thalamide. Again, the second step, when you give alkyl halide, what happens? You know that in this bond, when you cleave this, it will get negative charge and it will have positive one, right? So what happens here? This positive will attack this, and from here minus kx will be removed. Got it? And R. Now do nothing, just put it in the water and in the presence of KCl, H2. Okay. So when you give H2, what happens? So these two bonds will break out, right? And this will get H and this will get OH. Again, this will get H and this will get OH. What happens next? So here you can see that R and H2, that is primary amine will form. Okay, and this will be converted into a salt, O minus, right, and K plus, O minus and K plus, right? That's how you get the primary amine from thalamide. This is very important reaction. Mark it, very important. Gabriel thalamide synthesis. Sometimes they ask in the conversion also, just how you convert the thalamide into primary amine. Okay.